Welcome everyone to one of our very exciting Engage podcasts. We'd like to welcome you. We're going to discuss something different along the lines of residential load management. And there's been a lot of action in this space with a lot of noise being made by larger municipalities, power producers like Eskom and other informal power producers. But today we're going to try and just unpack the essence of the residential load management environment. I'm joined by Mr. Mornay Viljoen from EBT. During the past few months, EBT has become part of the Greater Business Engineering group of companies, and we're delighted to have them. And they're really a technology partner in our space, and we work very closely with them to align the offerings. So what we'll see is this type of technology flowing through to our ERP environment, and so all our customers stand to benefit greatly from this relationship in the medium to longer term. Mornay, if you would maybe just take 5 seconds just to introduce yourself, and then we can get into the action. Thank you, and welcome, Mornay.
Morning, Philip. Thank you very much. It really is very nice to have a discussion with you this morning. My name is Mornay Viljoen. I'm the CEO of Express Broadband Technologies, or as we refer to it, EBT. We've been active in the municipal space or the local government space for just over the last decade, and our mission as a company has always been to look at the innovative ways of how we can change the way municipalities operate and the way that the residents benefit from it. And this objective that we talk about today, residential load management, is something that we are heavily focused on now, and that we believe will have a great impact on making a difference on the financial sustainability of municipalities. I look forward to the discussion.
I agree with you. I think the whole sort of management of electricity in the country is very, very pertinent, and especially if we look at the costs and the reduction of the cost to the consumer. I'd like to perhaps just start off with some background. If you could give us some ideas. I mean, this is not a new technology. Municipalities have been doing this using something called Ripple. Maybe you just want to explain the whole Ripple control process. And then I also understand that Eskom are about to launch, or have launched in the early 2000s, a similar component. Maybe if you could maybe just give us some background on that, please.
Certainly, Philip, quite correct. The technology that we refer to is known in the market as a Ripple. And essentially what it does is at certain periods of the day, with this infrastructure installed in houses, and it was installed and connected to residential geysers, and in some instances to swimming pools. And essentially what it allowed the municipality to do is, by a press of a button, it'll switch all of those devices off. This was used already in the early 2000s, and with relative success for the technology that was available at that time, municipalities got that benefit. I think it's important to look at why this is necessary. Now, we must distinguish this between time of use billing and normal residential billing. Most of the municipalities, as a residential customer, you pay a certain amount of rand per kilowatt hour that you purchase from the municipality, and it's on a bit of a scale, so the more you buy, the more expensive per kilowatt hour per unit it becomes. But that's the only difference that it is. Eskom and the municipality deal in a different way. Essentially, on time of use billing, Eskom charges a different amount during peak hours where the demand is high, and off-peak hours where the demand is low, when there's more electricity than there is what is required on the grid. And it is significant. The price difference, Eskom, I think on the latest published figures, during winter peak periods, charges about R6.70, R6.80 per kilowatt hour. And they only sell that to their consumer at R3.70 or R3.80, I think, at the top end. So essentially, the municipality is making a loss during 5 hours of the day, which is regarded as peak periods. Now, in any business, like a municipality, is like any other business, it's not really good to sell your product or your service at a loss. And what the ripple control allowed the municipality to do was to switch off at a press of a button a blanket and a whole swath of geysers and swimming pool pumps to say, we won't sell electricity at a loss during this periods, let's say between 6 o'clock in the morning and 8 o'clock in the morning, 6 and 8 in the morning, and 5 and 7 or 6 and 9 in the evening. So it took the control of those devices out of the hands of the residential owner, and they just switch it off, and your geyser wouldn't go on and your swimming pool didn't go on. And that was to get away from those time of use billing tables and essentially selling electricity at a loss during that time. And that was ripple control, and that was the way it was used. Although it did what it was supposed to do, it also had its drawbacks. It was a on-off. You couldn't diagnose a device on a device level in a specific residence. You couldn't gather any additional information. There's no bi-directional communication where you can see there's something wrong on site. We need to send out a team to go and investigate. None of that. It was carpet bombing at its best, but it did serve a certain purpose. Modern day technology allows us to deploy the devices and being able to manage that geyser on a device level and gather information which is shared bi-directionally between the device and the control room and our data centers, which gives us access to information to make more informed business decisions. And let me give you an example. Say, for instance, there was load shedding in an area and the ripple control was also switched on, and the load shedding was over and the ripple control was also switched back on, so that all off rather, so that all the geysers and all the swimming pumps can work. What happened generally was all at once, a massive load of demand was dumped onto the electricity infrastructure. Now, firstly, from a technical perspective, this is not good. From a service delivery perspective, this is not good because there's usually trips and people complaining. Now people in call centers must answer phones, log calls, teams must go out, they must reconnect areas, etc., etc. And all of this happened purely because there was no visibility and data available to see what is on, what is off. It's just everything is on or everything is off. And we can't systematically switch them on this area first, or these 2,000 units first, then the second 500, and then the third 400, etc., etc. And that is what the modern day residential load management technology allows us to do. So if it's okay with you, I think at this point, if there's any questions, let's accommodate that.
I think it's a very good background. Thank you very much. I'd like us to perhaps maybe now focus on, the technology that we have. We've got a little device that we call a Spark, and third, fourth generation load management device that we install in our home or will install in homes, and that has specific characteristics. Now, I'd like you to just focus on that, because what I'd like to do is for us to then perhaps just also tie that into the functionality with the Collab Citizen app that has been deployed widely at most of all of our customers, a great number of municipalities, just so that we, sort of demonstrate in the next, let's say, 3 to 4 minutes, just how we tie the loop so that we make it easier. There are many systems out there that do geyser management and all these types of things, but that's not essentially what we do. I think we've got a lot of other value-add services, and if you could perhaps just allude to those, it'd really be great. Thanks, Mornay.
Right, Philip, so let's look at it firstly, as I've previously stated, and as you've correctly mentioned now, it's a device that is installed and connected to the power supply of the geyser. And that enables us to manage on a device level. In other words, an individual geyser gets managed. We know whether it's on and whether it's off. Many of the users and municipalities will be familiar that Some of the residents install the geyser-wise technology, which allows you to set your geyser to go on and off in certain times of the day. And the purpose of this is for cost saving. We know that generally water heating and geysers, for that matter, makes up about 45-50% of your electricity consumption. And with the electricity prices where it is currently, that's a significant cost. So it makes sense that consumers would look at deploying technology to assist them to bring those costs down. And switching your geyser off during certain periods of the day where it doesn't need to be on, that is a good thing. So essentially what this means, we've got control over the device. The device is connected to the cloud. You've got a Colab Citizen app. The device is registered through your Colab Citizen app. And essentially what the municipality has just given you is a geyser-wise function or a geyser-wise capability. You now, with the app in your hand, have the capability to say, I'm going on holiday from this day to that day. And on your phone, you can set the dates and you can instruct the geyser to be switched off during those periods. Or you forget about it and you travel, and when you're at your holiday destination, you tell your wife, like I normally do, I forgot to switch off the geyser. No problem. You can just go into your app.
Oh, that's brilliant. That's actually very exciting to see that we have this technology. Just on the specific device, maybe from a confirmation just from your side, I mean, I understand that it has been approved by CASA. It's got really interesting inherent functionality. So you can download software, so we can actually maintain that device over a prolonged period. What do you foresee the lifespan of a device to be if installed in a house? I mean, there's obviously a benefit for the municipality. There's definitely a benefit for the consumer. But it's a bit of an intrusive process because somebody needs to get access to a house, install this device, install it into a specific area. And we don't want to really, we want to ensure that we do that as little as possible, perhaps just maybe once during the life cycle of this device. Do you have any idea of how long the perceived lifetime of the specific device is?
Yeah, Philip, I mean, I think if you look, once again, if we take a leaf out of the Ripple control book, although there's a lot of that system that has collapsed to date, but there's also some of that system that is now 20 years old, which is still operating and running. And these devices could easily and should all easily, and is designed to easily last a decade plus. So I think it's safe to say that you can, between, I'd say, 10 to 15 years is easily a comfortable life cycle of the device. It all depends, obviously, whether the house gets struck by lightning. That will change the lifespan of it.
Yeah, for
but
sure.
also, how technology change. I think that the pace at which technology changes will outrun or will force a decision on whether this technology should remain in place or should be replaced with something new, rather than the device, being old and doesn't function anymore. It's not really a lot of moving parts, so it's quite robust and could easily, like I said, be a decade and a half. And on the current financial models that we are working on, a municipality could easily recover the capital expense within a 3-year period, and from there on being profitable. So, it's very attractive if you can deploy technology to assist you in reaching your financial objectives, and also be able to recover that cost in a short period. If you look at a device or infrastructure that lasts you 10 years, a decade plus, and you could recover the cost of that, especially the capital cost on that within a 3-year period, I mean, that's a very strong business case that should give any CFO good reasons to proceed.
Yeah. I also would maybe, just reaffirm the fact that this is not new technology. And we've been doing what we've been doing for quite some time now. Maybe just tell us a bit more about our testing center and what we test, how we test, just to sort of demonstrate the capabilities that we've been building during the past year or so.
I think that's where today in the technology environment that we operate, what makes it really exciting and what highlights the big difference between the old Ripple systems and what we are capable of doing today. We've got a state-of-the-art access to a lab down in Nelson Mandela Bay. And in our lab, various geysers of various sizes are installed in various configurations, horizontally, vertically, etc., etc. These geysers have been running on our equipment now, along with our technology partners, for on about 3 years. And what happens typically is, geysers are 150-liter geyser is 150-liter geyser. And if it's installed in a town, in the same kind of environment as other 150-liter geysers, and it's installed horizontally, it will behave more or less the same. So what happens, and where this technology becomes really powerful, is where we gather data, live data from installed environment, and we compare it to what the templates are that we already have in our lab. So we know if a geyser is set certain temperature, horizontally installed, and in this environment, and it's a 150-liter geyser, this is the amount of electricity that it will use. And this is the time of the day that it will be switched on, etc., etc. And just like that, our devices will build a history of each individual house's user behavior when they use the geyser. And all of that information comes back. And this is vital because we built a profile of its geyser, and we use our own patented or our partner patented technology.
Excellent, Mornay. Thank you very much for the detail. In conclusion, I'd like us to perhaps focus on the municipal environment, because the municipality, in our instance or in most instances, will remain the primary customer. And we are all working towards creating financially sustainable environments, enhancing revenue, and looking at operational efficiency for all the municipalities in South Africa. So I don't think there's one municipal manager that will say no to any of the objectives of being more financially sustainable, collecting revenue to the fullest extent, and also achieving significant operational efficiency. Just in a nutshell, bearing in mind of the involvement of Eskom as a bulk service provider, bulk supplier, what would be one or two of the key issues with regards to building the business case for a Spark deployment in a specific municipality?
Philip, in fact, Eskom supports this very much. Eskom has a currently running residential load management subsidizing program where they will fund 3 million rand over a 2-year period, paid in tranches for every megawatt that the municipality can prove through measurement and verification, can prove that they've achieved this saving. In other words, shifted consumption from peak to off-peak hours. It's like we're doing now currently. And I mean, obviously, when we deploy, there is certified measurement and verification tools in place. So this is not a thumbs up. It's not like the old Ripple. We think we did this, or we can more or less calculate it. This is date and time stamp. This is official. So you have moved so much megawatt hour from peak to off peak on this day during that time. Eskom will refund and subsidize that capital outlay from the municipality at 3 million rand for every megawatt hour that they shift from peak to off peak. So there's full support from Eskom. This makes these projects, firstly, very attractive because it saves money and it gets your support from Eskom, but there are conditions. And one of the first conditions that needs to be adhered to is the municipality needs to be standing with Eskom. So when the municipality's relationship and the accounts and everything is sorted and on up to date with Eskom, then there's no problems. But from a principle point of view and from a policy point of view, this has got full support from Eskom. Also important, I think, Philip, which we just need to touch on very, very briefly. The whole energy market in South Africa is changing as we speak.
Very, very important point.
With
Yes.
the Electricity Regulation Amendment Act of 2024, which is actually active from January 2025. And this is a very, very exciting opportunity for municipalities, because for the first time, they are actually being prompted and forced and say, listen, you don't have to purchase electricity from Eskom. Here's other independent power producers, which you can purchase from as well. And for that reason, and it was also highlighted in the president's speech at the State of the Nation address, we again mentioned the committee that is set up to finalize the structure of the National Transmission Company of South Africa. Essentially what this means is Eskom is being unbundled, just like they did with Telkom in the telecommunication industry. The same is happening in the energy market in South Africa. They're taking away the monopoly that Eskom has always had, and they're unbundling Eskom and splitting it up into power generation, transmission, and distribution. And a specific company, state-owned entity, is put in place, the National Transmission Company of South Africa, and they are looking after the sale of electricity over the transmission network. This is very exciting because it liberalizes the market, and whenever that happens, competition comes in, and whenever competition comes in, the standard of the service goes up and the price goes down, and the consumers and municipalities at the end of the day benefit from it. So our technology and our view, and our long-term view, the short, quick win, the lowest hanging fruit, is simple residential load management. Get these devices deployed as quickly as possible and start selling electricity at a profit and stop selling it at a loss. Move that electricity consumption from peak to off-peak. This is a no-brainer. But on top of that, the further development in positioning a municipality to benefit from the deregulation in the electricity market is where the real long-term benefits lie. Tokenless vending, wheeling with independent power producers, being able to, on a real-time basis, make decisions on what's happening on your grid within your municipal area. Where could you buy electricity? Where is electricity cheaper now from? Is it cheaper at this point for tomorrow, cheaper from this independent power producer than with Eskom? Municipalities of the future will have a division with people sit and make decisions on where they're going to buy the electricity tomorrow morning, 8 o'clock. It's not like today where they just see to it that the lights are on and then get a bill at the end of the day that Eskom tells them this is how much you owe us. They will trade electricity in a 24-hour period. Tomorrow morning, 8 o'clock, they need to make a decision where they're buying this evening's electricity from, or tomorrow's electricity from which one of the 10 suppliers that's approved to them. And that's very exciting because that means the shackles of monopoly is taken off. And for those municipalities that want to think out of the box and advance the technology policy, they will be in a position to achieve that financial sustainability that everybody's talking about.
Well, that's very interesting perspective. You know, we've been looking at what's happened in Europe at large, but specifically in the UK, where actually, you know, power consumption are being sold on a per minute block, and you could buy the next hours as a municipality. You could buy power for the next hour from multiple service providers, not necessarily from one, which brings a very interesting dynamic to the whole billing concept. But I mean, that is a whole discussion for another day. I'd like to sort of conclude this session and thank everybody for staying with us until now. There's very, very exciting things in the pipeline, very specific what we're doing. And if we just look at the summary, I mean, our objective here is to provide municipalities with accurate grid demand data and information so that they could make real-time decisions. And that in itself will boost the operational efficiency and also work towards the financial sustainability in the medium to longer term. What's important now is that we understand and recognize that there is a technology solution. It is probably what IoT was supposed to be, and this is sort of in the more refined manner where we could. It's a usable scenario. It's not something that we talk about. It's technology that we have that's been deployed. If you would like to engage with us from a municipal perspective, please reach out to us. We'd love to come and sit with you and your organization, look at your historical billing, see what the possible savings can be or will be if we implement the technology in a proper structured manner. And you don't have to make any decision or any commitment before we've shown you the figures. And most of the data analysis that we do, we use as a guideline, because that sort of allows us to manage the success or gauge the success of the deployment. But once again, everyone, thank you so much for joining us. We look forward to engaging again on similar topics. Mornay, thank you very much for the time you took this morning to speak with us. Thank you, everyone. Have a fantastic day. For more information, please feel free to contact us on 0860 104 888, alternatively admin@be.co.za, or on any of our socials. We'd love to interact with you.